Hi guys, today we're going to be doing LeetCode 3403, which is the daily for June 3rd. Yeah, so just to explain the problem a bit, you're given a string word and an integer known friends, and basically, you're trying to find the lexicographically largest string from the box, lexicographically largest string from the box, and basically, it's a game, right? So in every round, we split the string into num friends number of strings. And they're substrings, not subsequences, which is very important. And basically, we're trying to find in every single round what is the lexicographically largest string from the box. So this one's actually not that bad. What I'll do, I'll share my screen real quick. Okay. So this one is actually not that bad, right? So what we're looking for is a lexicographically largest string. And we know that, let's say, the string is awesome. So I'll draw awesome here. And let's say we have 3 friends. I don't know if this is a large number of friends, but it's whatever. So let's just go through some rounds, right? So in the first round, maybe one thing could be A, W, E, and then that's one string, right? Then we have S, O, which could be one string, M could be one string, and E could be one string. Right, so that's one permutation, or I guess one division, I should say. There's other ones like, let's say A, W, E, S, like O, and then like M, E at the end, right? But first let's ask ourselves, what is the answer to this, right? So basically, if I asked you, what is the lexicographically largest substring of max length, let's say, well, first let's derive the max length, right? I mean, like, what is the max length of any one of the divisions? Well, that's easy, right? It's just n minus the number of friends plus 1, right? So let's say this has the length is 7 here. We have 3 friends, so 4, and then plus 1, right? So 4 plus 1 is actually, sorry, I realized I've been doing this with I've been doing this with 4 friends and not 3. Sorry about that. So yeah, we have 4 friends, and then this becomes 3 plus 1, which is equal to 4, right? So this is the max length of the string we can create, which makes sense, right? Like, for example, I could make another permutation division. I keep on messing that up, but division A, W, E, S, then O, then M, and then E. Right, and the max length of this is 4. Right, so let's just go here. What's the lexicographically largest string? And right, so essentially, there's one key factor you have to make note of. Note longer strings that have the same prefix as some shorter string is, I guess the correct grammatical thing is are lexicographically greater than the smaller string. Wow, that was a lot of words, but you get the idea, right? So we just want to look for any substring of length 4 or less that is lexicographically larger. So, intuitively, we can see that, well, like, if I just take a look at this string, I don't know if S or W comes after the alphabet. I'm pretty sure it's W, but yeah, so the answer here will be WESO, right? So what we're going to do is we're going to start at this index, and we're going to look for the largest string we possibly could, right? Because AWES is greater than lexicographically to AWE. All right, so, and one edge case we have to handle is what if we're at O, right? What if we're at O and we try to get a substring of length 4? That's gonna give us like an index out of bounds right here, right? This is pretty easy, so we can just take the minimum of like how many characters are left. How many left? And like the max length of the string, so max len. All right. Hopefully that makes sense. We're gonna jump right into the implementation now. Yeah. 1 second. All right. Perfect. So, what we're gonna do real quickly. Let me get my keyboard and stuff. Okay, let me reset this because I deleted some of my old code. But yeah, so first what we're gonna do is we're gonna handle edge case. We're gonna handle the case if num friends is equal to 1. If this is the case, we just return the word itself, right? Because if you only have one friend, you can't make any divisions, right? Because there's only one substring. So greedily, you can just say it's word. And this will just make our lives a bit easier. And now we're gonna store length of the word in variable n. Then, so we're gonna compute max len here. So I'm gonna say max len is equal to n minus num friends plus 1. Okay, now we're gonna start at the beginning index. We're gonna iterate until the end. And we're gonna say, and we're also gonna have an answer string. So string answer. And at the end, we're just gonna return an answer. Okay, so one great thing about C++ is that this if we have like, for example, Z and then A here, this actually compares strings lexicographically. So we don't have to write a helper method for that. So that's great for us. So what we're gonna do is we're gonna say string candidate answer is equal to word dot substring of the starting index plus the number of characters we're gonna take. So what is this? This is max len, and this is equal to the minimum of I plus max len. Sorry. Let's figure out how to do this. Okay, so we want. Okay, you know what? Let's just do this. So we have int and index equals, let's say, max len. Or actually, technically, it's substring. The first is the start, and the second argument is how many characters you want to take. So we'll say it's equal to max len, and if I plus max len is greater than n. Greater than n. Let's say greater than n. We're gonna set end index equal to how many characters we have left, which is n minus I plus 1. I think that should be correct. And you know what? Let's just do end index. And if candidate answer is greater than answer, we're gonna set answer equal to candidate answer. Okay, I don't know for sure this is gonna be correct. Let's see. Oh wow, okay. Just for fun, let's put in our old test case in there. And let's say we have 4 friends. Now let's run. Unknown network error. Okay, never gotten that. Okay, sorry about that. That was weird. Cool. Yeah, we were right. So W does come before S, apparently. Yeah, or after S in the alphabet. Let's try submitting this and see how we did. All right, 41%, not too good. 24% not too good. Maybe this is just like a lot of times like when you let's try resubmitting this and see if we get different answers. Yeah, okay, so I think this is just like minor implementation details. Let's see. Yeah, I guess this is basically what we did as well. This is a much worse answer, I think. I actually can't tell. Oh, okay, this is the same answer we did. But yeah. That's it for today, guys. Thanks for watching. Let's see what the hint was. Oh, okay, the hint was exactly this. But yeah, thanks for watching. Yeah.